Hello, Keith Rucker here at VintageMachinery.org. Guys, today I got a new little project that we need to get started on. I've actually had this in the shop for a little while now and just been looking for, needing to find time to get it worked in, and these guys are going to be needing this pretty soon, so I've got to kind of get it going. And we got Ginger up here checking things out as well. So what I've got here is a governor that goes on a case steam engine. This is what they call a flyball governor. It basically is what is used on the steam engine to keep the engine running at a constant RPM. With the stationary steam engine, unlike a locomotive or a traction engine or something where you want to be able to vary the speed of the engine, with a stationary steam engine, you want it to be pretty much running a consistent RPM all the time. The challenge though is when you put a load on it, of course, it's going to require more steam than when it's just idling. And that's where the governor comes in. You can basically set this to be running at a certain speed, and it is going to adjust the valve in here to keep this thing running at that particular speed. The way it works is really kind of simple. This is called a flyball governor because up here on the top you got these balls. This is connected to the steam engine. Whenever the steam engine is running, these balls are going to spin. Centrifugal force will cause these balls to actually come out like that, and when it does, it causes a valve stem in here to open up, which goes to a spool valve down here in this bottom part that allows the amount of steam to come in there. So when you put a load on the engine slows down, the balls come in, it opens that valve up a little bit more, lets more steam in, and then it will speed the engine back up, the balls come back out, get to where they need to be positioned, and it's kind of self-adjusting. So whenever you place a load on or take a load off, this thing is always adjusting as it goes. It's really kind of an engineering marvel, but still fairly simple in design, which is really a cool thing in my opinion. So this is coming to me from the Pioneer Harvest Fiesta Club up in Fort Scott, Kansas. They've got a big show that they do every fall. They have a 1915 50 horsepower case steam traction engine that this is actually on. And they use that to power a couple of different things around their site. That includes a sawmill as well as a thresher. They said the problem they've got with this particular governor is that it just does not seem to be keeping up under a heavy load. They think it's actually got some wear down here in the valve that's allowing some steam to bypass, so they're not able to get that full speed up because of the steam leaking in it. At least that's their theory. That's what they think's going on with it. So they sent this down to me, and my job is going to be basically to rebuild this. And I'm going to be honest with you, I've worked on governors before. This one is a little bit different than some of the other ones. I think when I get inside, it's going to be pretty similar. But basically, we're going to probably have to rebuild this valve down here is my guess. But to do that, we're first going to have to tear into it and take it apart. So first things first, this is exactly how I received it. It is filthy, nasty, oily, grimy. I think what I'm going to do is take this over to my parts washer and just get it cleaned up a little bit first so that I can actually start working on it. We're going to take this thing apart, try to evaluate what's going on with it, and kind of come up with a game plan on how we're going to go about repairing it. And that's what today's video is really going to be, really more about the disassembly and assessing what's here and kind of coming up with a plan to go forward. So let me get to work. I'm going to go get this thing cleaned up, and we'll bring you back and start tearing into it. All right, we just spent some time over in the parts washer, and I'm not going to declare this part clean by any means, but it's a lot cleaner than it was. And I think we can at least get in here and start working on it. As we start taking it apart, it'll be easier to get some of these parts cleaned up a little bit better. But anyway, we got to just get started on it. So yeah, where to start? I think the first thing I'm going to do is try to separate the top part from the bottom. There's two set screws on this. One of them is broken off, but basically this, one of them is loose, one of them is not. But anyway, that allows you to rotate this top around, and it should allow it to pull off. Probably have to loosen up this little coupler in here to help get it apart, but separate the two halves. That's what we're going to try to do first. So let's see if I got a broken bolt. There's a little bit sticking out on it. Maybe I can get in there with a pair of vice grips or something and get it to come on out. Let's give it a try. So again, just some set screws. This one here isn't even tight. We'll just pull it on off. But this one here, as you can see, the head's broken off on it. So I'm just going to come in here with a set of vice grips and see if I can get lucky and get it out of there without having to resort to whatever we have to resort to. Oh yeah, it's going to come right out. Good. All right. That should allow that to kind of turn on there, but I think I'm going to go ahead and loosen up this little connector here, and that should separate the top and the bottom, and hopefully we can pull this on apart. All right, that's already loose. Okay. Now, let's see if we can get them to separate apart here. Oh yeah, it's coming apart. All right. All right, there's a stem that comes up through here. I thought taking that nut off would do it. That's just a packing gland. There was some packing goes in there. There is a pin that looks like it's holding it in place right here. I'm just going to try to knock that pin out and see if we can separate it that way. So let me get a punch here. Yeah, there it goes. Just a little tapered pin. As you can see, knock it out from the small side. And now, yeah, that's going to come right out. So I'm going to go ahead and finish separating these two parts now. There we go. All right, I got the upper assembly and the bottom assembly, and I'm just going to set this upper assembly aside for the moment. There's that little packing valve. We got the little gland. You just put some packing in there and tighten that up, and that seals the steam up around that little area right there. Now I think what we need to do is we've got this piece right here. It looks like it's going to unscrew, so probably put this over in the vise and get a wrench on there and see if we can get that apart. All right, we're over here in the vise, and I've got a big 2 1/4 inch wrench. All right, it just came loose. This should unscrew, pull up, and that should allow me to pull the valve out now. There we go. Well, I've done some further cleaning on this and just kind of inspecting it and checking it out. This is the spool valve that's in here, and overall it appears to be in fairly good shape. There is a little bit of pitting on the valve here, but it's nothing of any significance, and I'm not going to put it in here right now, but when I do drop it back in there, I mean, it's a very tight fit. There doesn't seem to be any real slop or anything in there that would allow steam to be leaking around it or anything like that. And the pitting that I see in this is just individual little pits. It's not like a groove cut through there that would allow steam to escape. So I really feel like it's in pretty good shape. Now, the stem that comes through here is rather loose. That could be part of the problem, having some play in this, not pulling up and down in there, having a little bit of slop in the whole mechanism. That could be causing some problems. I do want to try to take this kind of apart and see if we can make some improvements there, but the valve itself, I think, is in pretty good shape. Let's see if we can get this nut off. They've just got a little ear that's kind of knocked over with a hammer that kind of captures that to keep it from turning loose. I'm going to see if I can loosen it up and get that screw to come out. See if I can kind of bend that back just a little bit. All right. All right, looks like we just got a brass stem here, and on the bottom is a little larger diameter piece that's pinned into place, but man, it's really loose. I have a feeling that this might be the biggest part of the problem with this valve right here. So just a little bit closer look at this valve stem. It's brass, bronze, something like that. And again, we got this little piece here that screws in and tightens everything down. It looks like there was a pin in there that this went around. Got the little notch there for that pin to cover up. And then on the bottom, there's this little ring that's pressed on, and it is pinned in place. But the pin is very worn. It's got a lot of slop in it. And I think what I'm going to do is I think I'm just going to make a whole new piece here and just replace this. I don't know why they chose to pin that piece on the end. It just seems like to me that it would be a better design to have this all one piece, just turn that out. I mean, I'm sure you're saving, you know, a little bit of material cost and so forth, but you could totally eliminate all of that movement down there if this was one piece. Something to think about. I don't really like to re-engineer parts on stuff like this, but we might just machine this out of a little bit larger piece, make that a one-piece assembly, and that might go a long ways toward improving the situation. I don't know, but I think that we will do that. I'm going to have to order some material to make that out of, but I think that will get some of that little bit of slop out of this valve down here, so you have more positive interaction when it's pulling that spool valve up and down. I know that's not a lot of play, but when you're looking at letting that little bit of extra steam in or not letting that little bit of steam in, that could be a significant role in their problem. Could be. And a fairly easy thing to fix. So I think that we'll do that. So when I look at the component of the spool valve and all that, I mean, that's really about all I can come up with that we can improve on. I really just don't think trying to do anything with this little bit of pitting in here, I just don't think it's significant enough to cause any problems, so we're going to leave that alone. But I do want to also kind of look at this upper assembly and see what we can do to maybe improve that as well. So we're going to make a new piece right here. That's going to go on my list of things to do. All right, let's look at the upper assembly of this. All right, so looking at the upper assembly, I mean, I don't see, again, anything that's just glaring major problem, but I do see some issues that we can probably work on. Number one, there's a lot of slop in this bearing on this piece here. So I would like to take this apart. I imagine there's probably some bronze bushings in there. Maybe we can tighten those up a little bit. I want to take all this apart and see if there's anything in here that we can work on to kind of improve, you know, bearings or whatever in. There's a lot of moving parts up here, and anything we can do to, while we're working on it, to prolong the life, I think now's the time to do it. So let's go ahead and take this thing apart so that we can evaluate the situation and see what we need to do to it. So let's start by trying to get this shaft out. There appears to be a pin holding this bevel gear in place here, and we'll see if we can knock that out. That is one tight pin. There we go. Looks like it's just a rivet. It's got a little bend in it. And that comes out. The gear drops down. So that's just cast iron on steel. I was kind of expecting there to be some bronze bushings in this, but this looks to be just cast iron sleeve there, and a steel shaft. So let me, I'm gonna get a micrometer and measure this shaft. I see a little wear mark right there. We might be able to replace that shaft and make it a little bit larger and take care of this wear in here. Let's do some quick measurements. All right, so after doing some inspection work, measuring here, we've got a good bit of wear on both the shaft as well as the journal that this is our writing in. So, you know, just using a regular micrometer and coming here measuring the shaft, we're measuring anywhere from 5 to 10 thousandths undersized. This should be 3/4 inch, which, I mean, it probably, you need to have probably a couple thousand clearance in there just for the oil or whatever, but we're measuring between 5 and 10 thousandths depending on where on the shaft. And then I took a bore micrometer and stuck up in here and measured this bore, and it's also oversized, and just measuring in as deep as I can go. I really can't get in from the back side back there. It's measuring, again, 10 to 15 thousandths oversized. So, you know, we've got 20, 30 thousandths of play in there, which is excessive. Is it that critical? Probably not. I mean, this is just rotating here, but I think we can improve that. And probably my game plan here is that I will take a reamer and run down here and just go a 64th of an inch oversized. So instead of having 3/4, that would be, what is that, 49/64, I think. It would just be slightly oversized. And then I will turn a custom shaft where the journal size will be a good rotating fit for this. And of course, we'll have to turn the ends down to 3/4 for the pulley and the gear to fit back up on like they should, because there's no wear in that area because there's no rotation going on. So make a custom shaft. We'll ream this out a little bit oversized and get that where take that slop out of it. Again, fairly simple process, just a little bit of machining work, but something that we can do to improve this. So, all right, let's continue tearing this down and see what else we probably need to do to help things out on it. So I'm going to start by unscrewing this little adjuster down here on the bottom. All right, let's got that out. Finish turning this on out. And so there's a little ratchet here that you can tighten the spring up with, and I should be able to put that on there, remove the ratchet, and kind of release the pressure off of that spring. This is how you adjust your speed, by tightening up this, putting more pressure on this ratchet to get your speed where you want it. Let's see what we got to do to get this out. All right, so I'm looking at trying to get this arm out of here. There's this spring in here is attached. You can see it's caught there and there on the two ends, and there's a pin holding that in place. This looks like the small end on this side, so I'm going to see if I can knock that pin out. Probably a tapered pin again. take a bigger punch here and just see if I can get it started. All right, I think that got it kind of down flush. There we go. That pin came right out. And now we should be able to pull this shaft through. See if I can help it along. Here we come, all the way out. This string and the two ends will come on out as well. All right. Gonna kind of just put these assembly back together here so I'll remember how it came apart. Moving along, there's a little pawl here. There's this, looks like a cotter pin holding it in. All right. There we go. And knock that pin out. That ball is loose. Let me get the other ones. All right, now we're getting somewhere. That whole piece just comes out. All right. And that rod there goes all the way through. There's a little like copper disc up on the top of it there. All right, I'm gonna go ahead and take these balls off the bottom too. Just go ahead and get them separated. And just like that, we've got this governor stripped down to its components. And I've got things fairly cleaned up between the parts washer and wire wheel on the grinder. Taken off years and years and years of grease and gunk and everything else. But all in all, I feel like this governor is in pretty good shape. Like I said, we just got a couple of things that need to be done to it. And that's going to be coming up soon in some more videos in this series that we'll have on this governor rebuild. We'll be coming back with you more later on.